Hello, everyone, and welcome back to the machine learning session. So we have entered into multivariate regression method, which we were doing in the previous class. In the previous class, you have seen how multiple inputs when you are going to take to grab one output. So for that, we are going to use scikit-learn library. We are going to use pandas. And yet today I have come across with a wonderful opportunity among all of you. Today, we are going to find out or we are going to predict by creating a machine learning model on car resale. All right. So, by putting certain inputs about a car, such as mileage, fuel efficiency, how many engines are there, all those details, when you are going to put, we will be able to analyze what is going to be the cost of that particular car. So mostly car 24, or if you are going to take Spinny, these are using these kind of models to predict the car resale car prices. So that is what we will be doing. Let me quickly take you to the data, what the data looks like and how you are going to analyze the input taking care of that. So let me quickly open the file in front of you. So here is car data. So I'm going to just take a look of it and arrange this data accordingly. I'm going to make it look little, yeah. And we have, now all these entries which we have kept, they look good. And the first column says car age, second column is mileage, third column is engine size, and fourth is horsepower, fifth is fuel efficacy or efficiency, and then we have resale value. Basically, this is our output. I'm going to color it in a different color so that you will understand what are our inputs and what is going to be an output. All right. So this is a predictive model which we are going to create. As the first rule, we are going to see whether there is any interrelation in it or not. So basically, let's see. We are going to select it and we are going to run an analysis. All right, so here are certain charts which is being created. So it's basically resale value and mileage, right? So there is a correlation, as you can see, when the mileage is decreasing, because we usually check the efficacy on the basis of that only. Then we are able to see the mileage. However, when we have multivariables as an input, to create the charts, or like instead of heat map, a scatter chart is going to provide much more business insights in it. That is what we will be creating by using Seaborn library. For that, today what we have decided, we are going to go to Google Colab. Previously, the model which we created, it was on Visual Studio Code, and this time we are going to create on Google Colab. All right, everyone. So I'm ready with my Google Colab. So first thing which we are going to take, first of all, I'm going to add my data over here. To add the data, first thing which you are going to do, you are going to upload it. So let me do it. I'm going to click on this particular file. Over here, the moment I'm going to click on this, this is an upload button which is going to come in front of you. I'm going to click on car release data and I'm going to click on OK. The moment I'm going to click on OK, it is going to be added. So as of now, it says unable to connect the runtime. I'm going to just refresh it once again. Once it is loaded, we are going to retry to add the data. Yes. Yeah. Now I'm going to click and I'm going to add car resale data. And now this time it is being added. So at first, what we are going to do, step number one. So step number one says import libraries, and our libraries are going to be import pandas as PD, import seaborne as SMS, import matplotlib as PLT, or next is from sklearn and tab. So these are, we are going to take the last one with matrices. This time what we are going to import, mean square and mean absolute error. Mean absolute error. These are what we are going to do. And the last one which we are going to do, import numpy as np. So all these libraries, once you have done, you will be reaching to the next stage, and next stage is going to be, that is our step 2. Step 2 is load data set. Now you must be wondering why we are using Google Colab, because I wanted to give you a greater exposure how you are going to utilize the platforms which are available to run coding programs, right? For your practice, in case if you're finding it difficult or you don't have your own systems, right? So what you can do, you can practice on any of the system without Python being installed in it. ये सभी के लिए अवेलेबल है, चाहे आपके कंप्यूटर में पाइथन अपलोड और पाइथन है या नहीं है। आप किसी भी सिस्टम में जहां पे आपके पास इंटरनेट है, आप गूगल कोलैब को ओपन करके उसमें साइन इन करके वहां पर आप अपने कोड को एग्जीक्यूट कर सकते हो, जो कि आपके लिए सिंपलर भी होगा और इजियर भी होगा। तो चलिए चलते हैं स्टेप नंबर 2 पे। दिस स्टेप नंबर 2 इज लोड डेटा सेट। डेटा सेट को लोड करने के लिए हम सबसे पहले एक डेटा फ्रेम बनाएंगे। डेटा फ्रेम इज इक्वल्स टू pd डॉट रीड csv and the data which we are going to take, that is, we are going to copy the path. Here is the data. When we are going to enter, first of all, we are going to see print first 5 rows of the data set. That is what I would like to convey. Okay. Yes. I've done that, and print df dot head. This is what we are going to call up. So this is what, if we are going to run it, let's see. Now you can see first 5 rows are there in front of you where you can see. So our data is uploaded successfully. Now we will be reaching to step number 3. Step 3 is, now you are going to visualize the data. Now, understand the project which we are creating today, that is a real time project, which is on industrial level project. So you can mention this project in your resume that you have run a predictive model for resale car values. All right. So this is going to be beneficial for all of you. So we are going to visualize the data to find dependency. So for that, first you are going to write print slash n visualizing future versus real value. That is what we will be putting in. We will starting from here. Right. Done. Once we have done that, the next part which we are going to run, that is going to be What features do we have? That is what we will be putting in the list. Car type or car age. Then mileage. So whatever the way it is written over here, in the similar way you are going to write mileage also in the W in single quotes. Then I'm going to put, and in the single quotes, I'm going to write engine size. Then I'm going to get horsepower. Then I'm going to get fuel efficiency. All right. So these are all values which are going to be impacted. All right. So because all other, the next part which you see resale value, that is our output. So as of now, we are going to cater to car as well as car age, mileage, engine. All right. Have we taken engine size? Yes, engine size is being taken. So this is the value which we have taken as of now. So once you are done with that, you are going to move to the next one. Over here, what we are going to do, we are going to put for loop. For features in features. Here we are starting. What we are going to do, we are going to use an SNS dot TTER scatter plot. And over here, we are going to get started. X is equals to DF, and we are going to call upon all these features like engine size and all. So I'm going to take all of it. I'm going to put inside it. Yeah. It is done. Fuel efficiency. One more thing will be here only single quotes. Now, this is what is being done. Now, the second part which you are going to do over here. So that is what we have done. PLT dot title, and that is what we will be doing. F formatted string, we are going to start. Feature, it's feature, right? We have features, right? Because we have defined here as features. So everywhere you are going to mention features, okay? Feature versus resale value. All right, once you are done with that, PLT dot X label, and what you are going to mention over here, resale value in resale value in N in rupees. All right. Once you are done with that, you are going to move to the next. PLT dot Y label. Now, in Y label, what we are going to mention? Features. First of all, we are going to mention resale value. That is X label. In X label, we have mentioned features. All right. Features. Yeah. This is what you are going to do. Second, Y label you are going to mention in rupees, because rupees we wanted to mention in Y. Now the third one, PLT dot grid. We wanted to create a grid. If the grid value is true, all right. Now the next one, here you don't want it as a string. It should be value grid, grid true. All right. The next part which you are going to do, true. Next you are going to do, you are going to PLT dot show. Now let's see how it is going to code which we have written. So we have visualized versus visualizing future, and now we are going to create a scatter chart. So let's quickly run and let's see how it is going to go on. Now, catering to the features versus resale values, the first chart is being created versus car age versus resale value. So if the car age is increasing, resale value you can see, right? So it has a scatter chart. So there is no such like, visuals. So it's like scatter everywhere. Whereas when you are going to see mileage versus resale value, you can see some linearity in it, right? You can see that the cluster is like somewhere linear. When you are going to go ahead and when you are going to see engine size and resale value, that is also almost scatter. Whereas horsepower versus resale value, this is also like in the increasing order, right? Fuel efficiency is again the scattered. Now let's run our own analysis. So this is how we can see that yes, there is dependency on it and we can see certain changes in that, right? Now the next part which we will be creating, that is how you are going to run the prediction. We are going to create a correlation heat chart with it. So for that, what you are going to do, we are going to call upon SNS. So step number 4, correlation using heat chart, all right, or heat map you can say. So let me quickly write heat map. All right. Now what you are going to do, SNS dot heat map, and you are going to put DF dot CORR. This shows correlation. All right. Once you are done with that, you are going to put and you are going to annotate the way we have done in the previous class. True. Now what C map you are going to create? C map is equals to cool, warm. So this is what you will be creating. All right. Now, once you have done that, what you are going to do, you are going to put the title PLT dot title, and you are going to put the title as correlation metrics. And now the next part which you are going to do, you are going to PLT dot show, and done. Now let's quickly see how it is going to show. All right, I'm going to run it. Now here is the correlation matrix. With that you can see car age doesn't make much difference. It's 38%, whereas mileage, which was showing some linearity over here, you can see the linearity in the mileage. That is absolutely 76%. Car engine is the least, or you can say fuel efficiency is least. Because if you are going to take a high branded car, means Mercedes and all, the fuel efficiency is very, very less in that. So it doesn't make much difference, right? Now, horsepower, up to some extent, it makes that difference, and car engine size also matters. So we are going to take all these into consideration when we are going to provide resale value to it. Now, let's quickly get started with how you are going to create X and Y. So we will be defining input and output, and then we are going to split the data. So we are going to define X, which is our input. So how we are going to do that? We are going to df drop and we are going to drop Y from it. Resale value, which is at X is equals to 1. So when we are going to drop this value, we will be getting X. Now this is DF, and we are going to put resale value. So this is what we will be doing in that. So we have defined our X and Y. Now we are going to train the data onto this particular aspect. So now let's quickly split the data. For that, this is our step 5. And in step number 5, what we are going to do? Train, test, split. We are going to put X, train, X, test, and similarly, wait, X test, Y, train, and Y test is equals to train, test, split, X, Y. Then we are going to define test size, test size, we are going to keep 0.2 because the entire data is 100. Random state is equals to 32. This time we are going to keep 32. You can keep any random state, it doesn't matter. Now what we are going to do? We are going to put hash train model. So now we are going to train our model. Model is equals to linear. Now you must be observing the same steps which we have been doing from linear regression as well as multivariate regression. All the four, this is fourth model which you are creating, and in all the models, all the steps are same. Whether you are creating multivariant, only the scatter chart plot and how you are doing. So these little phenomena or algorithm is changed. However, all the steps are same. So what you are going to do, you are going to put this and then model dot fit. You are going to put X train and Y train. This is going to train your model. All right. Now, once you are done with that, you are going to make step number 8. Step number 7, basically, and that is going to be Y predict is equals to model dot predict on the basis of X test, right? So let's quickly do and let's see how it is going to go. But it is not ended here. We are going to see there are further more steps in it. So let's run till here and let's see. So here are all the charts which are being created. I'm going to move little down so that you can see. So here is the correlation chart. And now till now, we have not seen any print command we have not given. So after this, if you are going to give any print command, it is going to go ahead with it. So let's quickly do that. Before we do, we can see print y predict. Now let's see. We are going to predict that. So it is going to create a prediction. Now you can see the prediction of 30, not 30, 20. So you can see the prediction is being created like 37, 39, 32, 21, 25. So these are all prices. All right. These are all prices. Now what we are going to do? we are going to actually see what exactly is going to be, you can say, the errors in it. Basically, there will be a difference between the actual value and the real resale value that we have kept, right, from the testing side. So that is what we are going to see, the difference between the actual and the predicted. So for that step, what we are going to do, we are going to call upon matrices, which is mean absolute error and mean squared error. So that is our step number 8. So let's quickly write that. Step number 8 is evaluation. And in evaluation, we are going to write MAE is equals to mean absolute error, and mean absolute error of what? Y test on the basis of X test. So that is what we will be doing. Y credit. Once you are done with that, what you are going to do, you are going to print MAE. All right. Or first of all, let me do this. Value dot dot dot. Now I'm going to write print MAE, right? Now, same thing you are going to do with squared value. All right. So you are going to just copy it, paste over here. But before that, you are going to copy this and you are going to put over here. Here you are going to write RMSE. All right. And instead of this, you are going to write np.sqrt. And then you are going to call upon mean squared error. And then you have all this. Now there is one more. This is mean absolute. All right, not median. So kindly make sure that you are going to make this change. Okay. Yeah. So mean absolute error and mean this. Now you are going to print, and in formatted string, if you want, you can do that. So let's see. Okay, there is one mistake which has been done. So here instead of MAE, you are going to write RMSE, right, which we have defined. Now you are going to run it again. Let's see all the values. Yes, now you can see 1.62 and 1.88. So these are the values which are going to come. I think this is an acceptable values, not much difference. Now what we are going to do in the next class, we are going to find out the difference between the actual and the predicted value. So we are going to compare actual and predicted in the next class. Till now, let me just quickly revise what we have created. So step number 1 we have done, we have imported libraries, we have imported pandas, seaborn, matplotlib, pyplot, we have done scikit-learn, numpy. We have load the data by taking the path and using pandas data frame. We have visualized the data, and this time we have used for loop. At every point with each and every input, we have checked the correlation by putting scatter chart of it, and we have seen how each input is going to impact our output. Then we have seen the correlation by using heat map. Therefore, we have created X and Y. We have split the data by using scikit-learn library. We have trained the model by using model fit. And then we have predicted the value. Thereafter, we have calculated the error, where we have seen the error percentage over here. Now, the next step which we are going to do, we are going to see the comparison of both the values, the predicted value as well as the actual value. And thereafter, what we are going to do, we are going to predict a new value for the resale car. So that is a new part which we have not done in the previous segment. In the previous segment, you must have seen that we have just calculated the predicted value, as well as we have seen how it is different. This time, a new thing which we are doing, that is we are predicting the resale value based on the actual and the concluded value. So stay tuned with us to learn more. Until that time, everyone, goodbye and keep learning.